Hello humans, my name is Professor Leach and today we're going to start off by talking about the Quiz X results because this is an issue of how we read math and also why PEMDAS is trash. So if you would recall, last week I had you evaluate this expression 2x divided by 3y minus 1 for x equals 9 and y equals 2. I just had you type out what your answer is, show your calculations and type out your answer. And here were the most popular answers in this class. Of the 34 submissions, the most popular answer was 2. The second most popular answer was 18/5. And the third most popular answer with only one submission is 11. So there's a reason that I listed all the popular submissions. And it has to do with why PEMDAS is trash and should be tossed out as such. Not only did I give this quiz to y'all, I also gave it to my algebra class, which is Math 120. You might be familiar with that one. And in Math 120, 2 was once again the most popular answer, but followed by 11, and the least most popular answer was 18/5. Only 2 people said 18/5. I'm pretty sure at least one of the 2 people that said 18/5 knows one of the students in my Calc 2 class and might have just asked them because they were worried. Because in Calc 2, the most popular answer was 18/5 with 32 submissions for that one. The second most popular answer was 2. And back to being the third most popular answer is 11 with 4. So you'll notice that among all my students on the same quiz, the most popular answer was 18/5, but this is being heavily outweighed by the students in my Calc 2 class. So there's 49 total submissions for 18/5, 47 votes for 20, and only 9 votes for 11. So this quiz was about reading this expression and how you read this expression and how we read expressions in general. What's the most common usage is the thing that we're going for here. All right, so if you're worried about which one is correct, I gave credit for any of these 3 answers. If you put 2, 18/5, or 11, you got the point. It was only a 1-point quiz. 1 question, 1 answer, 1 point. So this might be run contrary to what you've heard before, because I hear a lot of people say things like, well, it's math and there's always one answer. And that's clearly not the case. That is just factually incorrect. So let's talk about how I wrote this expression and how it was deliberately designed to create this conundrum, this thing where we have 3 possible answers. So the reason I'm giving credit for all 3 answers is because the problem was deliberately designed to be ambiguous. It was deliberately designed to start a fight. And a fight it started. So I was a success in that regard. So that's why everybody gets a point for one of these 3 answers. Like if you put like South Dakota, I wasn't giving a point for that because that would be weird. All right, let's take a look at how, depending on the answer, how you read this expression, because I can tell by what you answered how you were reading this expression. The answer you picked reveals how you read the expression. if you answered 2, then you were looking at the expression like this, as 2x divided by 3y, then minus 1. So with parentheses, this is how you read the expression. You put the 3 and the y together. Because you're looking at this as 2 times 9 divided by parentheses 3 times 2, then minus 1. So you put the 3 and the y together and then did multiplication and division from left to right. 2 times 9 is 18. 3 times 2 is 6. 18 divided by 6 is 3, minus 1 is 2. So if you wrote 2, this is how you were reading the answer. You put the 3 and the y, and in your mind, you put those things together, but you kept the one separate. You said, well, multiplication and division stops at terms, so I'm going to do the minus 1 last. I'm going to take care of multiplication and division left to right, except the 3y is in parentheses. The important thing to notice here is that by inserting these parentheses in your mind, you were not following PEMDAS. So in this case, you were not using PEMDAS. So if you looked at this problem and said, I'll follow PEMDAS, and came up with 2, you did not follow PEMDAS successfully because you did not do multiplication and division from left to right. You put the 3 and the y together. By reading the 3 and the y together, you don't do multiplication and division from left to right. You did not do multiplication and division from left to right. You put the 3 and the y together. Even though 3y literally means 3 times y. So you were not using PEMDAS. Let's move on to the second most popular answer and how you were reading that one. So if you came up with 18 over 5, when you looked at this expression, you saw everything that comes after the division symbol as one factor. So if you said 18 over 5, then you were reading this as 2x divided by everything after it, 3y minus 1. This is a very popular reading for students that were in my Calc 2 class. And it was a very popular reading for students in my 130 class, and it was not a popular reading for students that were in my algebra class. I have some thoughts on why this might be the case, but let's go through and make sure that this is how we were reading it if we said 18 over 5. So we have 2 times 9 divided by the difference of the product of 3 and 2 and 1. So 2 times 9 is still 18. 3 times 2 is 6 minus 1. 6 minus 1 is 5. And, well, that's where we stopped. Some of you said 3.6, which is fine. 18 over 5 is exactly 3.6. And it shows me what I wanted you to show me anyway, that once again, you were not using PEMDAS. Because you did this subtraction before you did this division. And division should go before subtraction unless parentheses, and our original expression had no parentheses. So you were looking at the 3y minus 1 as one thing. So you looked at 3y minus 1 as one thing. Strictly speaking, there's nothing wrong with this. If this is how people are going to read expressions, then that's kind of the way it has to be. Look at the most popular readings. The most popular readings, at the very least, look at 3y and say that's one thing. That multiplication is one thing. If you answered 11, then you did strictly follow PEMDAS. If your answer was 11, then you did definitely use PEMDAS, because you read this as, when you see 2x divided by 3y minus 1, you were reading this as 2x divided by 3 times y minus 1. Because literally 3y means 3 times y. Multiplication and division go in order from left to right. At the same time, from left to right. Here you are using PEMDAS, because you said this is 2 times 9 divided by 3 times 2. 2 times 9 is 18, divided by 3 times 2 minus 1. 18 divided by 3 is 6 times 2 minus 1. 6 times 2 is 12, minus 1 is 11. If you got 11, you applied a strict reading of PEMDAS. You did not put the 3 and the y together. You read it as 3 times y. That's a multiplication. Multiplication and division go at the same time from left to right. So this is a strict reading of PEMDAS. Because you did multiplication and division left to right. You did multiplication and division from left to right, and 3y means multiplication. You said 3y means 3 times y. That's multiplication. It goes after the division because we're going from left to right. So you said, I'm going to apply a strict reading of the PEMDAS, multiplication and division from left to right. There's nothing that actually connects 3y together. There's nothing that says I should change the order of operations because there's no parentheses in the original expression. Any questions? Now, the interesting thing happens when we take out the number parts. The interesting thing that happens is when we take out the variables and just stick in numbers. I think I said the opposite of that. Because people that are putting this reading on this expression are also the ones that are going to jump into that Facebook fight that said 6 divided by 2, parentheses, 2, I think it was 2 minus 1. 2 plus 1. It's not really, that's not really the issue. The same people that said 2 or 18 over 5 will turn around and look at this one and say, oh yeah, that one, yeah, divide first, then multiply. And they're like all strict reading of PEMDAS until they get to this. If you put a variable in over here for the 2 plus 1, they're like all, nah, group those things together. That's an example of rules that are what I refer to as terrible. To me, that this means PEMDAS is like a speed limit rule. We only follow it sometimes. We only follow PEMDAS sometimes. In this scenario, when it's all numbers, we follow PEMDAS. But if we see a factor like 3 times y, then we mean something else. And that is bad rules. So what's going on here, the important thing to take away from this is that, first of all, there is a difference between the common way we read things and the rules that we try to enforce, this is not really an issue as long as we don't say, make this question, this ambiguous question, valuable and worth points. As long as there's no punishment for how we read this, then it's not really an issue. If we're just having a conversation and I drop this expression and you're like, oh, 18 over 5, I might go, oh, wait, hang on, sorry. I meant 2x divided by the 3y in parentheses and then subtract the 1. Then you're like, oh, okay, 2. If we're having the conversation at that level, then it doesn't really matter. But if I put this on a test exactly as is, it is a bad question. Putting this question on a test exactly as is like pulling someone over for going 72 miles per hour in a 65 zone. Technically, they were breaking the rules, but technically these people were breaking the rules and it's super common. And even though technically you were breaking the rules for going 72, if everybody is going 80, then going 72 clearly can't be wrong. We have to update the rule set because it is not how things work anymore. Here's another example of how that works. Using the word literally now means emphasis. I'm sorry, grammar, the people that are really invested in your grammar, and I know that it's not supposed to mean that, but it does now. I've had to deal with the fact that begging the question now just is the same thing as raising the question, even though it shouldn't be. The language has evolved. We get to say begging the question when we mean raising the question, and only super pedantic people like me are going to notice. I'm going to be like, oh, God, I hate it when people do that. You're raising the question. You're not begging the question. But that's just what that means now. Math shouldn't be this way. So my point is, this question is really poorly written. And if you're going to stake points on things, if there are going to be penalties in play for not reading the things that you, reading things the way you want them to be read, then it's on you to communicate properly. So this is ambiguous. If whichever one I want you to do, I can use parentheses and I can communicate the expression. I can write the expression clearly. The expression is badly written. I can improve the clarity with parentheses, so I should use parentheses to improve the clarity. So the point is, this expression is badly written. This expression is poorly written. Add parentheses and speak clearly. If you add parentheses, you can communicate clearly. 2x divided by parentheses 3y close parentheses minus 1. Now we're all going to answer 2. Now there is one correct answer. 2x divided by parentheses 3y minus 1 close parentheses. I know I'm just spelling these at you, but now there's only one answer, 18 over 5. 2x slash 3 in parentheses, then times y minus 1 will get you 11. No questions. There's only one answer if it's written this way. Communicate clearly. So the reason I think I always bring this up is that this question comes up a lot. And I see a lot of people who would answer this question as 2 and 18 over 5 say the division comes first, 6 divided by 2. They read the problem as 6 divided by 2 times 2 plus 1, because multiplication and division go from left to right. But then they get to this, but Then if I give them the expression, they're like, instead of answering 11 because they're going to do a strict reading of PEMDAS, they're going to tokenize the 3 and the y, and they're going to read this as everything that comes after the division symbol is divided by. So they're reading it as 6 divided by, parentheses, 2 times 2 plus 1. Or 6 over 2 times 2 plus 1. This is why using the word over when writing expressions is very bad. Very bad habit. But if you answered 1, you're not doing a strict reading of PEMDAS unless you have parentheses here. So 6 divided by 2 times 2 plus 1 is 3. 6 divided by, these parentheses say to take care of the multiplication first. 2 times 3 is 6. And so you get 1. This is a badly written question. I know that we can come at an answer using a strict reading of PEMDAS, but the strict reading of PEMDAS is not always applied. You can see that the strict reading of PEMDAS is not the most common thing. It's the least common thing by a very wide margin. And there's no difference between saying 2x divided by 3 times y and 2x divided by 3y. If we do want to make that distinction, we're creating very bad rules that are difficult to follow. Because if the multiplication involves a variable, then we put those things together. If it doesn't involve a variable, then we don't put those things together. That is a very bad rule. It's starting to look like football rules. And football rules are terrible. It's okay if you like football. I used to like football too. But the rule set is awful. It's like, oh, was his knee on the ground before he dropped the ball? Oh, he didn't really drop the ball, though, because the ball hit the ground, and the ground can't cause a fumble. We want these guys to slam into each other really hard, but we don't want them to hit each other. Did he hit the guy? Did he accidentally grab his face mask, or did he deliberately grab his face mask? You know what I mean? It's a terrible rule set. It's weird and arcane, and you have to look at things in super slow motion. And you can challenge calls that the referees make, but only a limited number of times. So it's not really about the truth and getting the call correct. It's about whining to get your way. Every time a coach throws that flag on the field and says, oh, I want you to replay, they're whining because they didn't get their way. What a bunch of babies. Football is stupid. Most of the things that we like are stupid. The sports that I like are stupid too. I'm just saying. I don't know if it's changed because I haven't watched baseball in a long time. But if you come out and argue at the umpire and say, oh, you got the call wrong, he will just throw you out the game. He's like, oh, no, you got to leave now. So what are we talking about? Oh, yes. My point is the expression was deliberately poorly written. And that's why I gave credit for all the popular answers, 2, 18 over 5, and 11. Because there's a reasonable reading for all of these answers. And if you want to argue that the 18 over 5 reading is not reasonable, I would argue that it most certainly is reasonable. It most certainly is. It was the single most popular answer. And the popularity grew. The popularity of 18 over 5 of reading the 3y minus 1 all together increased as the students' experience increased in the class. 2 out of a total 9. 2 out of 15, then 15 out of 34, to a majority, 32 out of 56. Experience increased the likelihood that you would answer 3y minus 1. Any questions? The point is not with how we should read PEMDAS, or we should go back and write some new rules. That's the wrong way to go. Write less rules and write your expressions better. Write clear expressions. Speak clearly. If we're not concerned with this kind of thing where we have to make sure that we speak clearly, keep in mind we have a whole branch of government just to interpret what those words mean. Because the words were written in English, and English is a terrible language for expressing, well, anything, because words don't retain their meaning for a long time. That is a good question. So I will say this, out of the over 100 people that did this quiz, exactly one student got the actual correct answer. Exactly one student out of the 100 plus people that took this quiz got the right answer, because only one student was comfortable enough, because they'd been in my class before, so they know what I'm like, was comfortable enough to call me out on my bullshit and say, hey, this question is ambiguously written. Are you trying to start a fight? To which I responded, them's fighting words. And then I owned up to it, and I said, absolutely. I was absolutely trying to start a fight with this particular quiz. I wasn't trying to start a fight because I kept your answers private. If I put this in a discussion on Facebook, then there would have been a fight. And people would have been like, oh, yeah, you gotta follow PEMDAS. Gotta follow PEMDAS. Then if I did follow it up with this one, oh, you don't have to follow PEMDAS. So if you encounter this on a quiz in my class, I'm clearly messing with you, and you should probably type, hey, I'm not gonna fall for your questions. I'm not gonna fall for this, you're trolling. And then I'll rewrite then I'll do the other stupid trick online. I'll go back and edit my original question so it looks like you're being mean. In a future class, I don't know what to do. I think the best thing to do is to not be so confrontational with some other professor. I would think it's funny, but you probably don't want to go up to a professor and say, and hey, Professor, not Professor Leach, I'm calling bullshit on this. Then they'll be like all offended. And you'll find out how fundamental they are in their beliefs, even though the professor would probably just, default to not following PEMDAS. So I would ask for clarification. This is the same thing if someone says something and you're like, oh, that could be interpreted a couple of different ways. Call them on it. What do you mean by that? Which is a great strategy. Someone makes a racist or a sexist joke. Best thing to do is like, I don't get it. Could you explain that to me? I don't get the joke. Same kind of thing. It's just the math version of it. So if I'm like, oh, 2x / 3y - 1, evaluate this for x equals y and y equals 2, like, oh, could you clarify what you mean by this with some parentheses? Because there are common interpretations that do not follow the rules that are in place. But that's because the rules are bad. PEMDAS is trash. Any questions? Comments? I know this was not a very trigonometry thing, but it's really important that we learn how to read what math is saying. It's really important that we learn how to read expressions. Part of learning how to read expressions is practicing writing expressions, which is really a matter of putting parentheses in the right place. Here's why this is really critical. Here's why this kind of reading exercise is critical from a trigonometry standpoint. Too often, we read things by form. We try to read things the same way we read, say, English or our native language. We don't read the words by looking at the letters and combining the letters into a word and then combining all the words into a sentence. We kind of take everything in at once. So it's really important in math to not try to take everything in at once and try to focus on what the expression is actually saying, because very subtle changes in the way we write something in math change what the expression means. And the same thing will happen in English, and plenty of other languages have certain idiosyncrasies, where small changes in the way something is phrased or written have large changes in the meaning of the phrase. So, for example, we have the distributive property. A lot of times we see the distributive property. And when I say distributive property, take a minute and just like type in the chat what you think of when you think of the distributive property. What does this phrase conjure? Well, not division. So what I'm thinking of is the distributive property A parentheses B plus C is equal to AB plus AC. I see what you mean. I wasn't talking specifically about the 2 times the 2 plus 1. But it would we certainly could think of applying it there. Normally, we encounter the distributive properties and we say A parentheses B plus C close parentheses equals A times B plus A times C. But this is a terrible way to learn the distributive property because it's teaching us a form where we have these parentheses. This works because this is A times B plus C. The reason that this operates the way it does, the important thing that we're leaving out, this is multiplication. It's not the parentheses that make this happen, it's the multiplication that makes this happen. It's not the parentheses that make this happen. It's the multiplication. It's not the parentheses that are making this happen. It's the multiplication. Parentheses is not an operation. It's just a way we group things together. These parentheses are just saying, hey, take care of this addition before you take care of the multiplication. We can leverage the fact that multiplication distributes over addition to rewrite the expression without parentheses. That's what's happening here. Multiplication distributes over addition. The real distributive property for multiplication and addition is that multiplication distributes over addition. Oops, I spelled I wrong. What we summarize with this A parentheses B plus C equals AB plus AC, what we're summarizing with that is this thought that multiplication distributes over addition. It works because this is multiplication, not because they're parentheses. Think of things that don't distribute. Exponents do not distribute over addition. If I have, say, x plus y squared, this is definitely not the same thing as x squared plus y squared. I can't just distribute the exponents. It's not the parentheses that make these things happen. It's the multiplication that makes this happen. If we have x plus y squared, this is equal to x plus y times another x plus y. So we get x squared plus 2xy plus y squared. If you're wondering why this is the case, it's because that's how numbers work. This is not some rule that we invented because we invented all these symbols for things, so we just kind of randomly came up with these rules. It operates this way because that's how numbers work. If I have 25 squared, that means 25 times 25. It does not mean, and I could, if I write 25 as 20 plus 5, which is how we're going to multiply this, it is not just 20 squared plus 5 squared. If someone told you that 25 squared was 425, you'd think you're missing something there. You got to multiply all this stuff. It's 20 plus 5 plus another 20 plus 5. So that's 20 times 20 is 400 plus 20 times 5 plus another 20 times 5 plus 5 times 5. That's the same, that's the way we would read 25 squared. Just because it's parentheses does not mean we can take that operation and distribute over addition. Furthermore, this is relevant to our interests. Trig functions do not distribute over addition as well. So if I have the sign of, say, theta plus phi, this is not the same as sine of theta plus sine of phi. Parentheses is not an operation. It's a grouping symbol. And this says to take the sine of, take phi plus theta, add those together, and then do the sine. It's got a distinct order to the operations, and they are not interchangeable. It's important that we learn to read expressions. And in math, the first big thing that we should be learning about reading expressions is how parentheses work. Any questions? I know we spent a lot of time on algebra in this particular trig class, but this is an important thing that often goes missing in algebra classes because we try to teach you algebra by programming you with algebra things like a times b, a parentheses b plus c equals ab plus ac. This is the distributive property. And it ignores the fact, the most important part of this is that it's a times the sum of b and c. It's the sum of a and b and a sum of the product of a and b and the product of a and c. It's the multiplication that makes this distributive property happen, not the parentheses. Any questions? Parentheses are how we organize things. Anyway, we went a little bit over time today. Sorry about that. But this is something that I think is important for us to hear. And I do this in every single class. So if you end up in one of my other classes, expect this quiz to happen and know that there's some sneaky stuff going on. Apart from that, I believe that's it. I'm done. Email this to your grandma, and I'll see you some other time.